Ayan. So once again, good morning to everyone. So if you haven't yet filled up the attendance, the link for that one is on the chat box. So I'm resending it to you now so that you can fill that one up. So as you fill that one up, let me go over our agenda for this particular session. So in this meeting, we're talking about the Gibbs energy, which was already introduced to you through the introductory video that we had that I asked you to watch prior to our sync session this morning. So Gibbs energy, the agenda that we'll try to cover are as follows. So we'll have the lesson proper. We'll also discuss some examples, followed by your questions and other concerns, as well as all other announcements. So for this lesson, we aim to achieve the following target outcomes. So by the end of this learning guide module, the students should be able to 1. Compute for the Gibbs free energy change using delta G equal to delta H minus P delta S. 2. Use Gibbs free energy to determine the direction of a reaction. And 3. To predict the spontaneity of a reaction using the value of the Gibbs free energy change. So last meeting, we were able to cover our entropy, and that led us to our discussion on the second law of thermodynamics. So we have learned that for all real spontaneous processes, the entropy of the universe will always increase. This gives us a criteria to evaluate whether a process is spontaneous or not just by looking at the delta S. So for any spontaneous process, the second law tells us na if you have a reversible spontaneous process, delta S of the universe, which is equal to the delta S of the system, plus the delta S ng surrounding, is equal to 0. Meanwhile, for an irreversible process that is also spontaneous, delta S ng ating universe is greater than 0. So there's a little bit of a problem with this one to use because in practice, it's really only the delta S of the system that we try to look at. So it's only the system that we're interested in by definition when we're doing an experiment or doing any kind of chemical change or physical process. So we don't really care much about the surroundings. And as you can imagine, the delta S, the universe rather, which is our basis to determine whether a process is spontaneous or not. So the universe is really a very big place. So what we try to do here is we try to come up with a criteria that only focuses on the system lamang without having to take into account what goes on into the surroundings and the larger universe as a whole. So let me animate this one. Okay, so we have the criteria in here. So let's say we have the following example to help us be able to measure our delta S for the surroundings. So you have in here your ice being held on the palm of your hand. The ice here constitutes our system that we are studying. And the process that's going on with the ice as it melts is represented by this chemical equation in here. So the solid ice is turned into liquid water. Its delta H is also known to us. So its value is given in this particular slide. So as the ice melts, what it does is it absorbs heat from our hand, which is part of the surroundings, that allows our solid ice to melt. So the Q comes into the system. And so we can also say na ang Q na ating surroundings is quite related to the Q coming into the system. We can then therefore define the delta S ng surroundings as the Q of the surroundings divided by T. Now, it's good for us because the Q of the surroundings has the same value of the delta H for this change, but having opposite sides. So that if we substitute the delta H here to the Q surroundings here, we now get equation 16. So again, since opposite signs sila, that's why you have a negative sign in equation 16. So if we use now that equation 16 into our criteria in equation 12, shown in here, so changing the delta S ng surroundings with what we got earlier, we now have the following. Notice here that I highlighted in blue the inequality symbol, the greater than or less than, greater than or equal symbol, because we'll try to see how that changes as we multiply both sides by negative t. Doing so multiplying every term by negative t gives us now the following. So notice na when we multiplied all the terms in this equation by a negative constant, ang ating inequality nag-flip over. From greater than or equal to, it has now become less than or equal to. And rewriting this one, so transferring the negative t delta s term into the second proportion, so we have the following. So we're already on our way to come up with a criteria that is solely based on the system. So all we need to do is just get rid of itong term na ito, which has the delta S for the universe. So here is where C. Josiah Willard Gibbs comes in. So that's him on the picture there. So Gibbs has proposed a new state function that allows us to express the spontaneity of a reaction more directly, which he called as Gibbs energy. So the Gibbs energy, capital G, is defined as in equation 17a. So that's the enthalpy minus the absolute temperature T times the entropy. The absolute temperature T is the temperature in Kelvin. Now, as with all of our other na mga quantities we've introduced, the internal energy, the enthalpy, the entropy, our G, we can also have an equation to express its change in a process. So we consider here, for our Gibbs energy, only changes that occur at constant pressure and constant temperature. So there are a lot of these, particularly the processes that go on in our body. So for instance, our cellular metabolism, it all happens under conditions of constant temperature. As you metabolize the food that you eat, the temperature of your body stays the same. Hindi naman siya umaakyat unless you have a fever. And it also remains at constant pressure. So unless you go deep diving into the sea, up to a depth of extreme depths, so our pressure that our body experiences just remains constant. So considering these na mga conditions, we can now define delta G of the system as follows. So that, using the definition of delta G for the system, we can now use this in here and substitute to our criterion. So we come up with equation 17b. So we now define that the delta G of the system is equal to the delta H of the system minus T delta S of the system being less than or equal to 0, according to equation 17b. So this now gives us a useful tool to be able to assess the spontaneity. So notice, dito sa ating equation na ito, all of the terms in here, this first term, this term over here, and the T delta S term, so they only talk about the system na lamang. So no more need to worry about what's going on sa ating surroundings or the universe as a whole. We only just need to focus on whatever change it is that is occurring. Now, coincidentally, d delta G can also be computed using the Gibbs energy of formation. So just like the enthalpy and entropy, the standard Gibbs energies of formation, G degree F, can be used to calculate the standard free energy change of a reaction. So the standard Gibbs energies of formation, you can still find it sa Appendix B ng ating libro or any other textbooks that we might have. And we can use the Gibbs energies of formation in a manner that is similar to the Hess's law. So you have in here the equation for the delta G of the reaction at standard state. So notice that its form is very similar to Hess's law. So I have to emphasize it just looks similar, but they are not exactly the same. Because Hess's law, it merely deals with our enthalpy. So ito, magkamukha lang sila ng equation, but strictly speaking, this one is not the Hess's law equation. They just are computed in the same way. So ang delta G natin, guys, it can now have a positive or a negative sign. Just like with our delta E for the internal energy and the delta H for our enthalpy. So depending on the sign of the delta G, we can say that a reaction is exergonic or endergonic. By exergonic, we mean to say that the reaction is able to occur without the addition of energy. Meanwhile, endergonic reactions can only proceed after the addition of energy to the system. So then let's look at the possible signs ng delta G. If the delta G has a negative sign, like in this case, we then say that the reaction that we're given is spontaneous. That is to say, it is exergonic. And on the other hand, if the delta G of the system during a change is positive, that tells us that the reaction as written is not spontaneous. So it is said to be endergonic. However, if we take that same reaction given to us and flip it over so that the products ng original reaction are now the reactants and so on, so the reverse of the reaction is going to be spontaneous. And finally, in the case wherein you have a delta G that's equal to 0, we then have a reaction at equilibrium. Now, processes at equilibrium, we'll talk about it more in the succeeding quarters, but we can already introduce a little bit as to what we mean by that one. So let's say you have this reversible reaction in here. You have 2NO2 gas combining together to form the N2O4. So in this reversible reaction, we can write the forward reaction as follows. So 2 of the NO2 gas combine to form the N2O4. And in the reverse reaction, the N2O4 will break down to produce again the 2NO2. So to allow us to better visualize what's going on in here, let's look at this GIF. Notice yung mga arrows in here. It's pointed this one and pointed to this. So kanina, 2 of the NO2s have combined together to form N2O4. So here it is again. So they combine, forming N2O4. Now let's look at the reverse reaction. Let's just wait for the arrow to appear on the screen. Okay, combining pa ito. Ayan. So this one, you have N2O4. Let's see what happens to this one. It broke apart. So it formed again the NO2. So in reversible processes, ang forward na reaction and the reverse reaction are occurring at the same time. So it might be at the start na si forward reaction, it's happening faster than the reverse. However, there will come a time na si forward reaction slows down and si reverse reaction speeds up so that at a certain point, which we call as the equilibrium, the N2O4 na na-produce ni forward reaction is being consumed at the same speed as it is broken down into the 2NO2. So that tells us na at equilibrium, it's kind of like there is no longer any more change in the composition of the system. So any N2O4 that is produced, so kung ano mang madadagdag sa ating system na N2O4, it's being offset by the N2O4 that is lost when that other N2O4 breaks down to produce again the 2NO2. So that is our equilibrium condition. So the rate of the forward reaction is equal to the rate of the reverse reaction. But more on that one later on when we go into chemical equilibrium, somewhere around the second or third quarter. So our delta G, we have learned is possible to have a negative or a positive sign. Now, delta H and delta S can also be both positive and negative. So let's see what the effect of the sign ng delta H and delta S are on our delta G. Starting with this first condition. So let's say in the first condition, or the first case rather, that both the delta H and the delta S are positive. So when kaya will our reaction be spontaneous? So in here, so when you have conditions of low temperature, ang delta G natin is greater than 0. That is to say the reaction is non-spontaneous. However, when you increase the temperature now, for this one, our delta G will now have a negative sign. And since delta G is negative for spontaneous reactions, that's the only time where case 1 gives us a spontaneous reaction. So it kind of makes sense naman. So positive ang delta H natin, and we want na si delta G is negative para lang magkaroon tayo ng spontaneous reaction. The only way na maging negative ang sum nitong delta H and the T delta S term is that if ang T delta S term is very large. So sabi dito, si delta S is already positive. So the only way that we can make the T delta S term na isa-subtract natin very large is if ang temperature natin is malaki rin. So that is why we say that our reaction is spontaneous for case 1 only at high temperatures. But at lower temperatures, what happens is positive itong delta H natin minus a very small number. So, ang mangingibabaw is ang positive na value ng delta H. That makes the delta G in turn positive pag low ang temperature. So if you have a reaction like this one, what our delta H and delta S value here tells us is that if you want it to happen spontaneously, kailangan mo lang taasan ang temperature. Now let's look at a different case. What if ang delta H is still positive, but the delta S is negative? So in here, so positive pa rin ang delta H, ang gusto mo mangyari is dapat negative si delta G para maging spontaneous ang reaction. So positive ito, why does it keep moving? Positive ang delta H, minus T. T is always positive in sign. Delta S is negative. Negative times negative gives us positive. So positive, positive. Puro positive ito sila. So when you add them together, you'll get a positive delta G. So in this case, in case 2, so our delta G will always be positive no matter what. So then we say that our reaction will never be spontaneous at any temperature that you could have. So if you have a reaction like this one, it doesn't mean to say na if it's non-spontaneous, that it will not happen at all. So that's not what we mean. What we mean to say is that if you want this reaction to occur, you just have to input energy continuously to force this reaction to happen. Because otherwise, without that added energy, this reaction here will not take place. Since ang delta G niya will always be positive no matter the temperature. Okay? Now let's flip it over in our case 3. This time you have a delta H that's negative and a delta S that is positive. Again, bear in mind, delta G should be negative pag reaction is spontaneous. So kung negative ito, minus positive na T times a positive na delta S. So this gives you a negative term. So negative term in here and a negative term na delta H gives you a negative delta G no matter what. So that then allows us to conclude that the delta G is less than 0 at all temperatures. So no matter how cool or how hot our reaction conditions are, so this reaction here is always going to happen without us having to give an additional energy to it. And finally, so the last case that we could have is if parehong negative C, delta H, and delta S. So let's see what happens. So negative itong delta H natin minus temperature na always positive since absolute temperature pinag-uusapan. So it's always gonna be positive, never negative. So negative times positive T times a negative delta S, magiging positive itong second term na ito. So it's quite okay if ang temperature natin is low. So if ang temperature is low, this positive value will not affect the negative delta H so much. So that ang kalalabasan ni delta G is, it's gonna have a negative sign. However, if you now increase the temperature here in the second na term, so then, itong second term natin will predominate. And since this second term is positive, remember, negative times negative is positive. So then the delta G becomes greater than 0. So if you now have a reaction like this one, so that means to say na, just by looking at the delta H and delta S values, what we need to do is, we just have to keep this reaction happening at low temperatures so that it happens on its own. Because otherwise, if we allow the temperature to rise up to a certain value, so the reaction will now become non-spontaneous and kailangan na natin magdagdag ng energy. So that is how the delta H and the delta S will affect the delta G. Kung titingnan natin balik si case 2, or rather case 1 rather, case 1 and case 3, we see na if we change the temperature, our delta G flips over. In the case of case 1, from positive, pag high temperature, naging negative siya. In the case ng case 4 natin, if you increase the temperature, it flips over from being negative in sign to becoming positive. So this allows us to be able to control when a reaction could become spontaneous. So we have something called as the crossover temperature. So that is the temperature at which a positive delta G switches to a negative delta G or vice versa. So to find this temperature, we just set the delta G here equal to 0. So setting this equal to 0, we now get the following. So transposing the T delta S term to the other side ng ating equation, we now get the following. And solving for the crossover temperature, we now get the following. So at this temperature that we solve, that is the time wherein ang sign ng delta G natin will change. Either from positive maging negative or from negative maging positive. So this allows us to be able to know exactly at which temperature na natin pwede i-keep si reaction natin. So in the case of our case 1, let's say, once we know the crossover temperature, ang kailangan lang natin gawin is lampasan lang natin siya ng kaunti para lang maging spontaneous na si reaction. While in the case of case 4, that tells us na we have to keep our temperature below the crossover temperature. Because beyond the crossover, so the delta G will now become positive and you now get a non-spontaneous reaction. So that is how we can be able to control when a reaction can be spontaneous or not. Another means by which we can be able to force a non-spontaneous reaction to be spontaneous is by coupling it to another reaction. So you can have this particular reaction here in step 1. So at 375 Kelvin, the delta G for this is 140 kilojoule. So sige nga, can you please recall for me, pag positive ang delta G, so what does that mean for us? Is it a spontaneous reaction or non-spontaneous reaction? Pag delta G is positive.
Non-spontaneous.
Okay, thank you so much. So non-spontaneous. So unless we add some energy to step 1 will not occur. However, if you now couple the step 1 with step 2, which now has a negative delta G at 375 Kelvin, so then our step 2 basically provides that energy to allow our step 1 to occur. So if isuma total natin sa step 1 and step 2, we'll get the overall reaction as shown in here. And the delta G can now be added. So overall, the delta G value, as you can see, is negative in sign. So just by having the step 1 happening in tandem with the step 2, we now force the step 1 to be able to occur. Since the step 2 now gives the energy to allow the reaction coupled to it to occur. So this coupling of reactions is something that we can see in biochemical systems. For instance, in cellular metabolism, there are many steps in the cellular metabolism that are non-spontaneous. However, those steps are then coupled with a spontaneous step para lang together you'll get an overall reaction that is spontaneous. So we see that quite a lot with our biochemical systems and other na mga reactions as well. So at this point, let's try some examples. So let's say we have example number 1. So ayan, example number 1. So calculate the free energy change of a reaction using the following data. So we have the delta H for the system equal to this one. Delta S for the system is equal to negative 85.5 joule per Kelvin. And the temperature at which the change has occurred is at 298 Kelvin. So we are now asked to find the value of free energy change as well as determine whether the reaction is spontaneous under these conditions. So to do this, let's summarize first ang given data to us. So we have the following. And from this data, what we're supposed to find is whether we have a spontaneous reaction or not. To be able to answer this one, we need to look at equation 17b. So copy natin siya. 17b, ayun. So equation 17b, we have this one. So copying the equation 17b, we have the following now. So now let's substitute the values. So kindly please have your calculators ready so that we can follow along with this example. So as you get the calculators, let me type the values in here. Delta H ng system is negative 35.4 kilojoules. Minus the temperature, which is 298 Kelvin, times the delta S, which is equal to negative 85.5 joule per Kelvin. So notice by multiplying the T and the delta S together, so you have the Kelvin sa numerator dito, canceling out this Kelvin in the denominator for delta S. And ang matitira na lamang is the joule. So what I'd like you to do now, class, is kindly compute for me what is the value of your delta G. So what is now the value of the delta G for the system? Okay, so Danielle has his answer. Okay, can we have other answers so that we can verify if tama ba si Danielle or not? So we have a different answer from AC. Okay, can we also ask other people to see what their answers are for this one? Okay, so let's check the answer for this. So in here, if I multiply the second term to each other, what I'll get is the following. So I have negative 35.4 remains as it is. minus the product ng second term. So 298 minus 85.5 gives me now a value of, this becomes positive in value by the way, since negative na delta S times this one gives me a positive value. So this is now equal to 25,479 joule. So notice here na magkaiba sila ng unit. The second term is in units of joule, while the first term is in kilojoule. So you cannot add them up yet. The only time that we can add the two together is if ang ating first term and the second term both have the same units. So how do we do this one? You can do as AC and Danielle have done, which is to convert the kilojoules into joule. So sige nga, can you please tell me, how do I convert kilojoule into joule? Can anybody recall how to do that one? How to convert kilojoule into joule? Okay, so Earl got that one correct. Same with Danielle. You have to multiply it by 1,000, sorry. So to convert kilojoule to joule, we just multiply this by 1,000. So 35.4 times 1,000 gives me 35.4 times 1,000, 35,400. So adding these together, my answer now is equal to negative 35,400 plus 25,479. That's equal to negative 9,921 joule. Or I can express my answer here in kilojoules instead. So pwede rin naman siya na maging negative 9.921 kilojoules. So either answer is accepted to be correct. Okay? So looking now at the sign ng delta G, so can you please tell me, do we have a spontaneous reaction or non-spontaneous? So let's see what the class thinks for this one. So my answer is Danielle. How about the others? So what do you think? From the sign ng delta G, do we have spontaneous or non-spontaneous? Okay, so Zed and Rain both agree with Danielle that we have a spontaneous reaction. And that is correct. Since our delta G is negative in sign, we then say that our reaction is spontaneous. As an additional na lang rin for us to be able to practice that concept, so let's also try to determine, is it exergonic or endergonic? Maybe this time we can hear from other members ng class. So can you tell me, based sa sign ng delta G, do we have an exergonic or endergonic process? So other members ng class na wala pa nakapag-air out ng kanilang ideas. So do we have exergonic or endergonic? Based sa sign ng delta G. Okay, so we have the following answers coming in. So all of them agree now we have here an exergonic process. So when you have a delta G that is negative in sign, that gives us an exergonic reaction. Thank you for your answers sa example 1. So in example 1, let me turn it over to you guys. Are there any questions ba on how to answer this one? Okay, thank you, Danielle. Now let's try our example number 2. In this example, so we have the following. So for this reaction with the following data, let us now determine which of the following statements is correct. So here, all we need to look at is the sign ng delta H and ng delta S for us to determine when the reaction is spontaneous at all. So first, gases muna. So what do you think? Actually, naka-highlight na pala siya. I forgot to take out the highlight of that one. Okay. So, AC, Feliz, and Earl all say that it is letter B. So I think that was a giveaway since I already highlighted that one. I forgot to edit it from the last class. So how do I determine this one? So if you're good at memorizing, so good for you if you're good at it, you can try to memorize the contents of this table to help you be able to determine under which case siya na belong. So in this case, you have our example number 2 belonging to case 2 with a positive delta H and negative delta S. And from case 2, we have learned earlier na the delta G will always be greater than 0 regardless of the temperature. We can also try to analyze it in a different way. So if you're a little more mathematical minded, we can take the equation ng ating delta G. So let me copy it here para may reference tayo. And try to analyze ano bang magiging sign ni delta G given the signs of delta H and delta S. So in the given information, sabi dito, delta G is positive in sign. So this is minus, let me highlight that in red. Temperature, again temperature, at least the absolute temperature is always going to be positive. Celsius and Fahrenheit, pwede sila maging negative. But when we're talking about Kelvin, it's always positive in value. So never do we get a negative Kelvin na temperature. So temperature is positive times the delta S, which is negative. So this negative delta S times the negative over here, multiplied together, gives us now the following. So copy ko na lang para mas mabilis. So multiplying the two negative terms together, I now get a positive sign. Now since positive pareho ang ating dalawang terms, we then say na our delta G has no way of being negative in value. Delta G for the system will always be greater than 0 no matter the temperature. So that is how we're able to arrive at the answer na letter B. So since kahit na anong taas pa natin ng temperature dito, we can never get a delta G that's negative in sign. So we then conclude na the reaction is non-spontaneous for all temperatures. So that is another way that you can try to determine or predict based sa delta H and delta S whether you have a spontaneous or non-spontaneous process, and at which conditions siya magiging spontaneous at all. Okay? So in example 2, so let me check on with you guys. So any questions ba on why we answered letter B for this example? Okay, so glad to know na none naman. So thank you Danielle and Phileus for that one. Then we have our example 3. So in here, I already copied for you the values na nasa Appendix B ni Silberberg. So S solid, the sulfur solid is actually represented here by the sulfur in its rhombic form. And you also have the water gas and the SO2 along with the hydrogen. So calculate daw the standard free energies of the reaction using the standard free energy of formation given in the table on the right. So let me copy the equation here. So again, this should be already quite familiar to us. We've been using it a couple of times already. So we have an equation here that looks very much like our Hess's law. Again, let me emphasize this one. This is not Hess's law, strictly speaking. It's just that they look similar, but they are not exactly the same. Pag Hess's law ang pinag-uusapan, so we're talking about enthalpy. And this is Gibbs energy, not enthalpy. So sige nga for this one, can you please dictate for me? So what should I write para sa products? So products muna tayo. So can you tell me what I should write here? Okay, so Danielle already typed the entire thing. So please don't forget the units for this one. So for the products, you have your SO2. So that's 1 mole ng SO2 times the Gibbs energy of formation ni SO2, which is negative 300.2 kilojoule per mole. Again, notice that the mole here cancels out the mole that it is multiplied with. And ang matitira na lang is kilojoule. Plus, for our hydrogen, we have 2 moles of hydrogen times the energy of formation, which is 0. Minus our reactants. So we have, so copy ko lang yung type ni Phileus for this one. Daniel rather, sorry. So we have the sulfur rhombic. So that's 1 mole of the sulfur times 0 plus 2 moles ng water times its energy of formation. It gives energy of formation, which is equal to negative 228.6 kilojoule per mole. Now, can you please compute for me how much this is? Okay. Can I ask also from the rest? Let's try to verify what Danielle has given to us, na value. So any other answers for delta G of the reaction? Okay. Side note lang, please always observe the correct number of decimal place and significant figures. So we have Phileus and Sham with their answers as well. So they both agree with Danielle. So this is 157 kilojoule. So in your final answer, only one decimal place lamang. It's because this one has one decimal place, while the other one in here has two decimal places. So since we're adding and subtracting them together, ang masusunod is the one who has the least number of decimal places, which is why our answer is 157 kilojoule. Okay? So that is how you compute the delta G for this particular reaction. So for this one, so let me ask muna you guys. So example number 3, gets lang ba how we answered this one? Or are there any questions regarding example 3? Wala naman? Okay, thank you. Sige, so let me summarize to you now ang ating lesson for today. So we were able to introduce yet another thermodynamic quantity called the Gibbs energy. The Gibbs energy is related to our enthalpy, the absolute temperature, and the entropy. So the delta G of the system is given by equation 17b as shown. Now our delta G enables us to predict whether a process is spontaneous or not just by simply looking at what's going on with the system. So unlike with that entropy change na, you have to look at what's happening sa system and the surroundings together. In here, you only need to look at the delta G change ng system. So sabi dito, if the delta G for the system is less than 0, the reaction is exergonic and it is spontaneous as written. However, if the delta G is positive in sign, you now have an endergonic reaction. That is to say, it is not spontaneous as it is written. However, the reverse reaction is actually spontaneous. Also, we can look up the free energies of formation. So that is in Appendix B of Silberberg to enable us to compute the standard free energy change of the reaction, delta G degree Rxn. So that basically wraps up our lesson proper. Okay, so at this point, let me turn it over to you guys again. So are there any questions ba or concerns that you'd like to raise regarding our lesson today?
No, sir. Ay, wait. Trick question.
Yes, please go ahead.
Other than sa Chem Alt na assessment, anong ipasa ngayon, sir?
Okay,
Alt.
so aside from that one, so again, what you need to submit is the alternative assessment natin. Remember the virtual lab na by group?
Yeah.
Yes.
Ayun, sir. So yung weekly na gina-answeran. Okay.
Yes.
Sige,
So
sir.
you need to be
Salamat,
able
sir.
to do the weekly formative assessment and the alternative assessment from 2 weeks ago. Okay? Other questions? Natapos na natin yung topic for today, sir. Yes, actually, we've already finished our topic for this week. Okay? Other questions?
Okay, sir. Last na to, ha?
Yes, please. Go ahead.
So, yung formative assessment na 1.4 ngayon or next week ipasa?
So what I need to have from you today para ma-checkan na is our 1.4 na formative assessment. Okay? So does that answer your question?
Yes, sir. Yes, sir.
Okay? Sige raw, let me check on as well sa ating alternative assessment. So were there any difficulties or questions you'd like to raise regarding that one? Any parts na medyo mahirap sa ating alternative assessment so that I know? Okay lang, the alternative assessment?
Okay man, sir.
Yes. Sabi ni Daniel, confusing lang minsan. Yes, that's the downside lang talaga ng hindi tayo maka face-to-face sa laboratory. So, really, we just have to try to do that one in our computer and it's quite difficult lang. Okay. So, ayun. The equations for the neutralization, all you need to do is you just have to look up. Ano ba yung chemical formula for the acid? Ano bang chemical formula for the base? And what will be their products when they react? So yun lang naman ang medyo difficult, I think. Pati ang pag-compute ng ating limiting reactants. Okay, other questions?
Yes,
Let's
sir.
test, okay lang?
Yes, sir. Yes, sir. Hindi ko sure kung pwede ito tanungin. Pero sa 1.4, anong ginamin mo dito yung ans? Hindi kayo, di ba? Answer. Tapos number 1, 57.3 kJ, 29.6 Celsius. Ano tong ginamin na 189 na J slash K joules slash
Okay.
Kelvin?
So problem solving kasi siya. So what we need to do, what I gave you is to allow you to be able to check your answers, if tama ba. So I already gave you the correct answer. So if you
So
didn't get the correct
isolve
answer,
ko, sir.
then you know na maybe you have to do something else.
Okay. So isolve ko para mahanap ang answer. Sige, sir. Sige, sir.
Yes, yes. Okay. Sige daw. Any other questions or concerns that we have? Sige. So if there are none, so very quickly na lang, let me go to our announcements. So we have now already, if you have a copy ng ating, printed copy ng ating LGs, you might have noticed that we've already done with our Module 1. So we have LG 1.1 up until LG 1.5. So next week, what we'll do, we'll spend the first portion ng ating time sa ating Chem 2 having our quiz. So coverage ng quiz will be LG 1.1 to LG 1.5. Types of questions that will be asked. So there could be a multiple choice type question, there could be a true or false, and there could be a problem solving. So those are the things that you need to expect. How many items total? I haven't yet finalized the number of items for that one. Pero ang time limit for that one, we'll try to do it in 1.5 hours. So that the remaining time ng ating Chem 2, we'll spend it trying to discuss what was going on with our quiz next meeting. Okay? So let me share K-Hub to you for a while. So I just want to show you something very quickly. So in K-Hub, you might have noticed in here, at the end of each week, For instance, below week 1, you can see in here the PowerPoints na ating sync session. So I highly suggest that you download this one to help you be able to prepare for next week's quiz. And also, I have made available the recording ng sync session. Now, there were some problems with this one. So some of you were asking permission to be able to view this one. So possibly na, I already set this one to be available to everybody, but somehow, hindi pa rin gusto i-share ni Google Meet. Ay, ni Google Drive rather. So what I'm doing, I'm just downloading the videos again. Then I'll upload it later on. And then I'll just give an announcement where you will find the recording ng ating sync session. So please check the announcements in here. Nasa pinakataas na portion ng ating K-Hub under sa Hello Students. So please check the announcements from time to time so that you can see where to find the recordings and everything else you need to prepare for next week. Okay? So na-follow ba yun? So again, just prepare for your quiz next week. So in the meantime, since we're already done with this morning session, so please take the time this afternoon to finish your LG 1.4 na formative assessment if hindi pa tapos. And also please be sure to submit your alternative assessment for the group. So team leaders or group leaders rather, please submit for the sake of your entire group na. Okay? So thank you so much for your participation today. So before we go, any other last questions or concerns that you might have?
None na po, sir.
Okay, thank you, Jazz. So, Sham, thank you as well. Again, please don't forget to sign the attendance today. So thank you so much for your participation this morning. Yes, Danielle, any question? Okay. So if na mali ng submit yung file sa alternative assessment, so maybe the group leader can ask somebody else sa kanyang grupo to submit. So I'll just check na lang. Okay? So okay ba yun, Danielle? Does that answer your question? Okay. Sige, so it's 12:07. So thank you so much for participating today. Again, please use the remaining time to submit your alternative assessment and answer the LG 1.4. In the meantime, so please enjoy the rest of the week. So good news, tomorrow is a holiday sa Coronadal, so we have some time off. So please enjoy your weekend. Stay safe always and see you next week.
Bye, sir.
Thank you.
Bye, sir. Thank you, sir.
Thank you, sir.
Thank you. So afternoon last na guys. We're already done for today. Just be sure to submit your assessments.